This is the walkthrough video for PCTC 24-25 round 2 question 6 square wave. So this question is actually quite difficult. There are so many different nuances and implementation problems with this, and there are loads of different ways you could have done this question. I'm just going to kind of approach it in what I think is the most intuitive way, but again, there are so many different ways, and it's not like my way is actually easy. So yeah, I don't know. This is a tough question. But we essentially need to simulate this wave with ASCII art given the input. So the easy bit, let's take in our input. And we probably want to convert it into a list of integers. So let's do int I for I in input. So now it's a list of integers. And we also want to slowly build up our wave. So let's say wave is going to be equal to an empty list. And the way I'm going to build up the wave is I'm going to build it up column by column. And then with printing that off in the end. So column by column, how many columns are there going to be? Well, we can first look at how many samples there are going to be. So how many samples are there going to be? Well, this is going to be the input divided by 2, because there are 2 numbers for each of our samples. So we can say for sample in range len imp divided by 2. I'm just doing integer division to keep everything in whole numbers, because Python likes that. So for each sample, what are we doing? Well, we need to kind of print this off. We need to kind of create a column for the amount of ticks that sample runs for. So how many ticks does that sample run for is the question. So we can look at our input, then we can go to sample, multiply that by 2 and add 1. And I believe this is the correct equation that would get us the correct number of ticks, because our samples come in pairs, and so that's where the multiply by 2 comes from, because for every sample we are kind of jumping up by 2. And within each pair, the duration is a second number. So within that pair, the duration is the 4. And that's where the +1 comes from. We want to get the odd index, not the even index. So this is the duration of each given sample. So let's write another for loop. Let's say for tick in range this. And for each of these ticks, we want to essentially create a column. So the column is going to be a dot multiplied by 10. So it's just going to be 10 dots. And then we want to change the column, or we want to change the cell at the index of the amplitude of the column to equal an @ symbol. And so what is the amplitude? Well, if you look at what we did up here, it's very similar, right? This extracts the duration, and so the amplitude is going to be the first number. So we can remove the +1, and this is simply the equation to get the amplitude. So that's the amplitude. So that's the index that we want from column that we want to change to an @ symbol. So yeah, we made pretty good progress there. Now the next thing we want to look at is this vertical transition between consecutive samples. But there's a slight caveat, which is this vertical transition only exists basically at the start of the next sample, and it only exists after a whole sample is complete. So it only exists basically here and here. It doesn't also exist at the start over here and or at the end over here. So let's write an if statement that accounts for that. So we can say if sample does not equal 0, so if you're not on the first sample, because the first sample does not have any sort of vertical transfer. So if we are not at the first sample, and we are also in the first tick of the given sample that we are at, then there is going to be a vertical transition. And the vertical transition, what is it? Well, that's just going to be from wherever the minimum amplitude was of this current sample in the previous sample to the highest amplitude of the current sample in the previous sample. So what is the current sample? Well, the current sample is basically just going to be this, so you might as well just copy that down here. And the previous sample is going to be a very similar thing, except that we just have to -1 from sample. And so now we can write our for loop. We can say for I in range, the minimum of current and previous, all the way to the maximum of current and previous. And we need to ensure that this is inclusive, so we have to have a +1, because we want to go not only from the minimum to the maximum, but we also want to include the maximum, right? We also want to include both sides, like both sides of this transition are @ symbols. So we need to make sure that that's included. So we can say, if I range that, let's take our column and take the index at I, or the cell at index I, and change that to the @ symbol. And this is pretty much all we need to create our wave. So now it's just a matter of formatting it, because if you recall, wave is a list of columns. But when you print stuff out, you print it off in rows. So we can use a very simple hack in Python, which is a transpose. And transposing is this specific command. you're better off kind of just memorizing this command as opposed to learning how it works. Although, of course, I do encourage you to learn how it actually works. But this command, transpose, basically just switches the columns and the rows, right? Which is exactly what we want, right? Because our wave is currently a list of columns. We want it to be a list of rows. So this is exactly what we want. Except the only problem is our thing is going to be upside down. And the reason it's upside down is because we've done our counting from the top, right? So whenever we've changed, like for example, col I is counted from the top as opposed to the bottom. Whereas in this ASCII art, it's counted from the bottom. Like this is amplitude 0, and this is amplitude 10. But we've done it the opposite way. We've said this is amplitude 10, or sorry, amplitude 9, and this is amplitude, sorry, yeah, we've said that's amplitude 0, and that's amplitude 9. And so since we've done it the opposite way, when we print off the wave, we to ensure that we do it in the opposite way. So we can say for row in wave in reverse, and this is how you reverse a list, we want to print off the row. We want to ensure we print it off correctly, so we can unpack it, so we can print off each element with a space between it. We don't want the space, so to get rid of the space, let's just say the separator between each of the elements is going to be an empty string, right? This is just an empty string. And so this specific command will print off in essentially exactly what we want, each element of the list without empty spaces between them. So these 3 lines are a bit confusing, possibly, if you haven't come across them, but they're very good hacks and techniques to know if you want to be able to kind of solve puzzles like these without too much hassle. And funny that I say that because we seem to have gotten the wrong answer. So let's just run on the test case and do some live debugging to see what's gone wrong. So nothing's being printed. Yes, very obviously. We didn't add the column to the wave. So we can do wave.append column whenever we create a column, which goes there. Now we should actually print something off and hopefully get those points. Nice.